people say, I've heard people say stuff like, well, you can only homeschool because you don't work full time. And I'm like, well, I've known people who have worked full time and have managed to homeschool successfully. I used to have a student who, she had her little sister, her youngest sister. There were only two of them, but her little sister was like severely, profoundly disabled and was in a wheelchair and didn't speak. Like she had a lot of challenges. And their mom worked close to full time and was in college full time and homeschooled those two girls, one of whom needed a lot of help and attention. So it is totally possible. You just have to think outside the box. What's on your shirt today? Oh, Super Mario. What you reading?
The Swift's, a Dictionary of Scoundrels.
Oh, I haven't read that. Is it good? Looks like you just started it.
Mm-hmm.
It's good. You like it?
So far, I don't know.
Whoa, hey, let me get my legs out of your bed. Yeah, so far so good. Awesome. Hey, good morning. How are all my peeps today? Everybody's good. Everybody's quiet today. It's like you're like, all right, folks. Let's see, we got just a few more minutes. This is one of my favorite, why is that stuck? This is one of my favorite lessons because I like the aesthetic of my slides for this lesson. It's all like candy and sweets and food, and you're gonna leave here hungry. Sorry. Oh, did you? Because you're gonna launch you some milkshakes. Oh, are these brownie points? Excellent. Good. There you go. Glad you found one. See, I forgot to put these out. Let me do that real fast. There we go.
Last year it was like a competition for brownie points.
Yes, it was. Last year it was easier to find the brownie points because last year it was easier to find the brownie points because I was using a lot of hand typed stuff, so I don't have a professional editor to come behind me and check for things like the textbook company does. This year you guys have the textbook, so you're less likely to find them unless it's like in my syllabus or something, which happens, or in my test apparently, Emerson. It happens. When I think of the volume of text that I've produced for this class, it's amazing there aren't more brownie points, because good gracious, like some of these courses I typed out like everything. Everything. Ooh, can't block that one. I'm sorry. That's coming from the high window. It's nuts. There you go. Let's say if you slide that way, it looks like you'll be good. It's crazy that certain times of the day it's blinding in here. I put the blinds down and it's still bad. Oh, do y'all remember last week? Some of you guys saw last week I had a downy woodpecker that showed up. Did anybody see him?
No.
So I had a downy woodpecker that showed up last week during class.
Did it look good?
Yeah, he's cute. He's a little they're little like kind of smaller woodpeckers. They're like kind of fuzzy looking. Like That's him on the feeder, right there. See, he's red and
Wow,
white and
that
black.
looks so cute.
See?
He looks like a tiny turkey.
Yeah, well, then I have a red belly, and here he is. And he's funny, because he's too big for my old feeder, and he used to fall off. He used to look really stupid, because he came on by his toes. But, yeah.
But there's also the sound.
Yeah, it's got sound too. Yeah, it's pretty cool. So I was happy to get the little red bellied guy because I've been watching him for years, like just hang off the old feeder and look dumb. So the fact that he like he's too big. So my old feeder had like a little circular base, like a plate, and then it had like a glass jar kind of on top, right? And he would fly up and he's so big he couldn't land on the little base, so he would grab with his little toes and he'd hang like upside down with his butt dangling beneath. And he'd like try and bend his neck over to get seeds. He looked, I called him the fool every time. Like, oh, the fool's back, because he just looks stupid. And so now with this feeder, he can actually sit on it. So he was taking his time and enjoying himself, but he's so big, he scares away all the other birds. They don't like him at all. So, but he's cool. He's cool. So.
He's the freaky one.
He's goofy. And I got, last week I also had a female purple finch, which means I probably have a male purple finch somewhere, and they're really pretty. So, hey, so I'm hoping I get to see him soon, because they're really cool looking. We got lots of, like mated pairs, like some birds will, oh yeah, I didn't need to keep that one, so I was just giving it back to you. A lot of them will like mate for life, right? Like the house finches will mate for life, so if you find one, you're gonna find the other. So when I saw the little female purple finch, I was like, ooh, because the male purple finches are like raspberry colored and they're really pretty. But I'm excited for summer because I get a lot more birds in the summer that aren't here in the winter. Like I do have an indigo bunting that comes every so often. Have you ever seen one of them? They're teeny tiny and they're bright blue, like the whole bird, not like a bluebird where like his back is blue and his chest is orange. Their whole self is like bright blue. They're really pretty when they're on the feeder along with the cardinal, because then you get the bright blue and the bright red.
There would be different types of birds.
Yeah, very different, but they're very pretty. All right, so we are starting Unit 7 today. And this is going to be all about solutions for these next couple weeks. There's
Solutions, acids, bases.
Yep, solutions, acids, and bases. And surprisingly, there's a lot to learn about these things that you think, oh, I know what a solution is, I know what an acid is, I know what a base is. Oh, but there's so much to learn. So we'll go ahead and get started on this. And like I said a minute ago, this is one of my favorite slideshows because I love the aesthetics. Everything looks very yummy. And today I have some special opportunity for extra credit for the unit test 7, which is going to be the end of this unit, but today is an opportunity. So here's what you're going to do. I have some bad science jokes, puns, and riddles all throughout my slideshow, like dad jokes, but worse. Some of them are real bad. Like you're going to go, oh my God, Miss Danny, by the end of the day, right? So pick one that makes you laugh, snort, roll your eyes, or face palm. Either it's kind of funny or it's so awful you can't believe I made you endure it. And then you're going to make a meme or a drawing that can represent your favorite one. And don't copy what I give you. Do something similar or make it a little different. Make it your own. Give me a meme. Give me something stupid. And then you can go into the forum. And there's already a heading in there. It's not under the lab group. So be sure you go into the one that says chemistry all. And there's a post there that says memes, do your worst. So give me your memes or your drawings for these silly ones. And if I see one from you, be sure that I recognize your name. Like some of you have names I don't. It's weird. Like your login name is one I don't recognize because it's something strange. That's fine. Just be sure you put from Lucy underneath. And then you can get 2 extra credit points on your test. Cool? All right.
I have a question.
Yeah.
So, can you give me an example for like, so you gotta, if there's a joke, you gotta like represent it in the photo?
Yeah. There's some memes in here already. I want you to make your own.
Oh.
But some of these are really bad. So
there'll be jokes all around this.
they're not all that hidden. They're pretty obvious, and some of them are like, oh, some of them are actually funny. So let's start with talking about mixtures. What is a mixture and what are the types of mixtures? Well, this little pile of sprinkles is a great example of a mixture. So when we talk about what are mixtures, I'm going to want somebody to explain to me why these sprinkles count as a mixture. So, oh, here's our first one. If you're not part of the solution, how's the rest of that saying go? If you're not part of the solution, it's a saying. If you're not part of the solution, you're part of the,
Precipitate, cause.
well, that's the chemistry joke, but most people would say if you're not part of the solution, you're part of the problem. But the answer here, whoop, if you're not part of the solution, you're part of the precipitate. Oh, that's pretty bad. And nobody laughed because it's terrible. But here we go. All right, so a mixture. What's a mixture? Oh, what kind of cereal is that? Lucky Charms. Who likes like guilty pleasure? Yes. Do you ever get the one that's like lots and lots of marshmallows or whatever it is, the extra marshmallows?
My mom gets the pack of jelly.
When I was a kid, it was pink hearts, orange stars, green clovers, blue diamonds. And they even said it in the commercial. That's why I know it, because they said it in the commercial again and again. But then they added purple horseshoes, and that was a big deal. And then they added rainbows, and then they added, yeah, stuff like that. So those things weren't in there when I was a kid. It was pink hearts, orange stars, green. What did I say? Pink hearts, orange stars, green clovers, purple diamonds. No, yellow, blue diamonds, whatever. You know what I mean? Anyway, yellow moons. That's right, yellow moons. So a mixture is a substance made by combining two or more different materials in such a way that no chemical reaction occurs. Would you agree that in this picture, we've combined cereal and marshmallows, and they're mixed together, but no chemical reaction has occurred? Yeah. And how do we know no chemical reaction has occurred? Do you see any of our signs? Yeah, none of these signs. No signs, right?
You could say that the milk changes color because of the color of the marshmallow.
That's true, but that's also going to be a mixture, and we'll talk about why. But a mixture can usually be separated back into, Annabelle?
Its original state.
Yes, its original components or its constituent parts. You could say that either way, but whatever it's made out of. Now think back to that pile of sprinkles. It might be hard because some of the sprinkles were itty bitty, but could you separate the sprinkles by size and shape, and then further by color? So you absolutely could separate them, right? That makes it a mixture of sprinkles. In this case, it's a mixture.
What did Michael Jackson say when he found 2 atoms of helium?
What did he say? So there we go. There's another one. Lucy's done. She's like, I can't already with this. Yes. Okay.
I'll send that to my dad.
That's a good one, right? All right. It's goofy, but I do like it. All right. So that's fun. That's fun. Hee hee. Why does he say hee hee? Helium, helium, right? Ooh, hee hee. It should say what, it says say what did, not what does. I was gonna say that's right, because he's no longer around. All right, types of mixtures. So we have 2 main types of mixtures. The first one is homogeneous, and you may hear me or other people say homogeneous. Some people pronounce it that way, which is, it's okay. You're going to hear it both ways. Most people these days are saying homogeneous, but back when I was coming up, we said homogeneous a lot. And in this case, it means that your particles are evenly distributed and not evenly separated. So they're pouring something, salt, sugar maybe, into that glass of water there. And it's going to completely dissolve, and we'll talk about dissolving, but it's going to completely dissolve. And would you say that the particles, say it's sugar, would you say those sugar molecules are going to be pretty evenly distributed? But it can't be separated. How could you separate this with a physical process?
Can you filter it?
You could filter it. It would be easier to do that with salt. Remember at the very beginning of the year, we had different salts at different temperatures, and we were able to separate the salts out. And then, that's fine. It's fine. It's not really, because it's just a guy that mispronounced it. It's really not. It's fine. Okay, so then, how about this? If that, let's say that is sugar, all right? And we left that glass outside on a warm day, and we left it for like 2 or 3 days, what might happen?
Water might evaporate.
Water's going to evaporate, and what's going to be left behind? The salt or the sugar. So in that case, was there any chemical change that occurred to separate the 2 things? No,
it was a phase change.
It was a phase, yeah, well, the water changed phase. So that's a physical way that those components are separated, right? But they're not easily separated. If it's a homogeneous mixture, it's not easily separated. You can't just go in there like the sprinkles, which might seem difficult, but compared to sugar and water, it's easy, right? Like you can physically separate the round sprinkles from the little Jimmy sprinkles or whatever, right? but it's gonna be a little harder to do this, but it can be done, right? Because it's not chemically combined. And then you have heterogeneous, or what some people will say heterogeneous. You'll hear it done both ways. And that means they're easily separated. Could you easily separate the types of berries in that bowl?
Yes.
Yes, because they are not chemically combined, right? Lucy, what's your favorite kind of berry of all those berries in the bowl?
Blueberry.
Blueberries.
Blueberries, strawberries.
There's strawberries.
Yeah, they're tiny little strawberries in there.
Blueberries.
Strawberries.
Strawberry, I like the raspberries.
Blueberries.
Raspberries.
Wait. So when it's the right time, me and Pawpaw will go.
That's okay.
Me and Pawpaw will go to the blackberry bushes and pick out blackberries and eat.
Does he grow them at his house or?
No, they just grow on the bushes.
Oh yeah, the wild ones.
And we'll just eat them straight off the thing.
I love them. And we have raspberry bushes that run down the side of our yard over here. And I love it because every morning in the summer when I go to let Ozzy out, I go out there and I pick 1 or 2, maybe 5, 6 ripe ones and pop them in my mouth. But you know who has the most berries I've ever seen is PJ, by the way. Her family has a crazy like setup. Their backyard is set up. They've got a whole fence and it's covered in blackberries. And I get blackberry jam from them every year at Christmas. It's great. So homogeneous or homogeneous can be separated, but the particles are evenly distributed and it's a little more difficult. Heterogeneous, you got particles that are easily separated. Now, of these two things, one of them is a solution. And that's going to be what, Annabelle?
Homogeneous.
Yeah, the homogeneous one is a solution, right? This is not a solution. All right, so let's see. Oh, I was going to make a joke about sodium and hydrogen, but nah. Okay, y'all are gonna really hate me by the end of the day. All right, so types of heterogeneous mixtures. All right, so we have what's called a suspension. Can somebody define a suspension? What's a suspension?
Suspension is when suspension is a mixture in which particles can be easily seen and separated.
Mm-hmm.
It's like a heterogeneous mixture.
Yeah, it's easily seen and separated. So what's in that little glass? Does anybody know what those are?
It's a lime.
There's a lime on top. Do you know what's in there?
Boba.
Those are chia seeds. Anybody ever had chia seeds like in a pudding?
I've heard of chia seeds.
Puts chia seeds in her poo smoothie.
In her what, prune smoothie?
Poo.
Oh, whoa, you call it a poo smoothie? Is it
Because
gross?
she started with it with the name.
Oh, okay, yeah. Yeah, well, that's fair. So they actually, those seeds actually, when they're put in water, they have a coating on them that will hydrate and it blows up and it's like, makes it like a little jelly ball around each seed. And because of that, they can float in there like that and they're evenly dispersed. So our definition is a mixture of a fluid that contains solid particles sufficiently large for sedimentation. That means that if you leave it long enough, they could settle to the bottom. Yes.
Oh yeah. Speaking of my Paw, today is their 2nd anniversary.
Oh, well, congrats to them. So yeah, so say you had a bottle of water and like, like a Dasani bottle or an Aquafina bottle, and you took the label off so you could see through it and you put in some glitter and you shook it up. That glitter would be all contained throughout the liquid, right? But over time it would settle. And in real life, the examples of suspensions that are actually like affect the world around us, there's lots of them. Like we're going to talk about blood in a minute. That's one. But also, like a creek bed or a river bed has small particles of sediment and sand and silt that are caught up in the bed, and it's called the bed load, and they flow through the water, right? But that's what scrapes the rocks on the bottom and makes your river rocks really smooth. So that's a suspension too. And if you were to get another one of those, say you have an empty water bottle and you scooped up some muddy water from the river and put it on your counter and left it for long enough, you get nice clear water on top and that sediment and silt at the bottom. So it's a suspension. All right, if I were a DJ, my name would be DJ Enzyme because I'm always breaking it down. Okay, you're gonna learn what enzymes are pretty soon, but enzymes are catalysts that speed up reactions.
Did you
And they can, huh? Bit, yeah, a little bit. We've talked about enzymes, but they exist in nature, right? So we'll be seeing some more of that later. All right, types of heterogeneous mixtures or heterogeneous mixtures. So what's a colloid? Do you know what a colloid is?
Colloid is a mixture that contains small undissolved particles.
There you go, small undissolved particles. So blood is also like a colloid, and we'll talk about why. Were you gonna say the same thing or?
So yeah, colloid is a mixture containing small undissolved particles that do not settle out but are larger.
Yes. Right, so a mixture in which very small particles of one substance are distributed evenly throughout another substance. So it's like you have one particle and it's kind of surrounded by the other particles. And a great example is milk. Okay, so milk that you get from the store has been homogenized, meaning it's been turned from a heterogeneous mixture to a homogeneous mixture. Pasteurized is different. So pasteurized is they temporarily, like really flash heat it real quick. And when they heat it, they're killing any of the bacteria. It's usually not in the milk because milk itself, it could be. But really what they're worried about more is bacteria that comes from like the cow's udders that are exposed to other things. But it kills all that bacteria so the bacteria doesn't grow in the milk. That's what pasteurized is. Homogenized is a process they put the milk through that keeps it so that when you're drinking it, it doesn't separate. Anybody ever, you heard the saying, the cream rises to the top? You ever heard that? So if you have non-homogenized milk, regular milk straight from a cow, you go out and farm and you pull on the cow's udders and you fill up a bucket of milk and you leave it, it will separate, and it will separate into like the whey, the liquid part, right? And then the fat, the cream will come to the top because the fat is lipid and it's less dense than the water and it'll float just like oil on water, right? And if you ever anybody ever babysit? Okay, so when you get older, if you babysit, if you ever babysit a breastfed baby, you'll see that example really clearly because human milk will separate the same way that cow's milk will with the fat on the top. And you see it and you have to shake it up before you feed it to the baby to mix it all back up together. So what element's name is derived from a Norse god? This is a real one. You know about thorium? Ah, that's a real one. Not even so much a joke, but more like a riddle or a question. There you go. So here's our homogenized milk. Let's see how they do it. Yep, it's a video. It shows you how it's done.
Oh, it's made.
Yeah, kind of.
Do you ever wonder what exactly is homogenized milk? Well, you're not alone.
Dear Organic Valley, I noticed that you have homogenized and non-homogenized milk. What's the difference? Great question. Here's one of our food scientists with the answer.
I'm Emma Grindy, a product development food technologist, and I've been with Organic Valley for 5 years. Homogenization is simply the process of breaking down fat molecules so the milk has a smooth and even consistency. Homogenization doesn't involve additives or chemicals, and homogenization doesn't alter the nutritional benefits of drinking milk. In its natural state, all raw milk is composed of protein, water, and butterfat. Left alone, the fat will rise to the top, creating an obvious layer of cream. This is where we get the saying, only the cream rises to the top. When milk is homogenized, it's heated, agitated, and passed through a valve at high pressure. This physical process changes the fat molecules so they are the same size and density as the rest of the milk. The result? Homogenized milk is always smooth and consistent.
That's really all there is to it. But if you would like to try milk with the cream on top, Organic Valley makes several non-homogenized dairy products. Grass milk whole milk, cream on top, grass milk 2% milk, cream on top, and our signature cream on top, grass milk yogurt.
Organic Valley products.
So if you ever wanted to try non-homogenized milk, you can buy Organic Valley brand, which I think they have at Publix. Oh, what kind of bears are soluble in water? Polar bears. Oh, this has something to do with polar molecules, which we'll talk about a little bit more next week. Well, what kind of bears are soluble in water? He says, help on dissolving, but bears are insoluble. That's easy for you to say. You're not polar. Ah, this has to do with water being the universal solvent. And we're going to talk a lot about what dissolves what. Yeah, well, it's fine, but because everybody's meme will be different. But here's the thing, the quick thing here is that like dissolves like, meaning polar molecules dissolve in a polar solvent. And non-polar molecules or solutes will dissolve in a non-polar solvent. So that's why, like, anybody ever wear grease paint or oil-based makeup for, like, yeah, for stage or for Halloween, you have to take it off with like a lotion or a cold cream or baby oil or something to get it off, because you have to dissolve it in something else that's also non-polar. That's the only way you're going to get it off. Whereas water, if they say water soluble, is polar. All right, so types of homogeneous mixtures. So we did our types of heterogeneous mixtures, and we had suspension and colloid, right? Now we're talking about types of homogeneous mixtures. So what's a solution?
Solution is a mixture that contains a solvent and at least one solute.
There you go. A solvent and at least one solute. Okay, a solute which is dissolved and a solvent which does the solving. What's that, you suppose, representing that
That-
image? Lucy, what do you think that is? In that glass?
Salt.
Water is a
It's not
precipitate.
salt. What does that look like?
Soap.
Not salt. It's bubbles. How about soda? Ah, is that Sprite?
To say that.
Sprite, club soda, soda water. What's dissolved in soda water? Carbon dioxide. We can dissolve a gas. It doesn't have to just be like some kind of a solid like sugar or salt. It can be a gas. Gas can be dissolved in water. Here's something very interesting. Gas dissolves better in water in colder temperatures versus solids tend to dissolve better in solutions in waters at warmer temperatures, but gas does better at colder temperatures. And that actually comes up in earth science when we talk about atmospheric carbon dioxide and ocean temperature, because there is a relationship there, and it's pretty interesting. All right, so what do you do with a dead chemist? Barium. I got a little chortle over there, a little you bury him. What else do you do with them? You bury him.
If they want, before they die, they can donate their body to science.
This is true. We absolutely can. Do you know what happens with those donated to science bodies? There's lots of different things that happen. Sometimes they will harvest tissues for research or whatever. Sometimes they'll go to what's called the gross anatomy lab, and not gross because ew, gross meaning large or full scale. And gross anatomy lab is where medical students learn to dissect and see all the structures within the human body. They'll run the human bodies through the same type of preservation process that they do for some of the smaller animals that will be dissected. Yeah, frogs, pigs, things of that sort that we'll be dissecting next year. They do all of that. And it's interesting. When I was in high school, I got to do that. I got to go to a gross anatomy lab at our local medical school and work on some of they're called cadavers at that point.
You got to dissect the human.
Well, I didn't get to do the dissecting. The med students were doing the dissecting, but I got to observe, and I did get to put my hands in there and stuff, and it's pretty cool. You did what? A touch of heart? Was it like a sheep's heart? A pig's heart. Yep. Yeah, they usually do sheep or pig. No, I've seen the pictures from it, but I haven't seen it. Is it good?
Yes, it's very good. I watched it the other night, and there's a scene where Wednesday, instead of dissecting the frog, brings it back to life.
Oh, that's fun.
Frankenstein.
That's fun.
I have a joke of my own. How is Wednesday so big and popular? She's in the Addams family.
Okay, there you go. All right, let's have a look here. Dissolving. Let's talk about dissolving. So dissolution occurs when a solute breaks up from larger particles, should say from larger, not a larger particles, into much smaller groups or individual molecules. This breakup is caused by coming into contact with what, Annabelle? Do you know? Solute breaks up and it dissolves when it comes in contact with,
Solvent.
a solvent. Very good. A solute is what's dissolved. A solvent does the
The dissolve.
dissolving. That's important to remember. A solute is what is dissolved. A solvent does the dissolving. I heard that oxygen and magnesium were going out, and I was like, OMG. I'm sorry, that was so stupid. It makes me laugh. It's so dumb, but it's funny. It's dumb, but funny. Okay. Solids and solvents. Okay. So again, everybody, what is dissolved? The solvent or solute? What's dissolved? Everybody. The
Salt.
solute is dissolved. And what does the solvent does the dissolving? So in this case, what's the solute?
Salt.
Well, look at it. It's in little cubes.
Sugar.
Sugar, yes. And then what's that probably? Water. Does sugar dissolve in water? Yes, water would be the solvent, sugar would be the solute. And then you just get really sweet water, right? Who likes sweet tea? Y'all are
Some-
Southerners, so you ought to.
Sometimes me and Mama have tea parties and we just get like this regular bottle of regular tea and like we just put a bit of, and I just put a bit of sugar and a bit of water in it.
Yeah. So one of my best friends that I go out to eat with a lot, she's another mom on the gymnastics team. So we go out to eat a lot when we drop the boys off for practice. I like tea. It's one of my iced tea is one of my favorites, but I don't really usually like sweet tea because they put too much sugar in it for me. It's like syrup at that point. They saturate it. I prefer unsweet tea with like one little packet of Splenda. I just want it to be a little sweet, and I don't put sugar in it. Usually I put Splenda in it, one, because of calories, and two, because it's ice cold and it's that sugar takes a while to dissolve. That solute is hard to dissolve in the solvent if it's cold. If it's warm, it does better, which we'll be talking about. But my friend, she likes it like sugar, water with like a drop of tea. Like, and I tease her about it all the time. I'm like, you are drinking sugar water with one drop of tea.
So is it true that blueberries help your brain?
Oh, I don't know. Probably. I mean, they've got vitamins and sugar helps your brain in general. You need a little bit of sugar.
Brain foods are rhubarb, pretty sure.
Rhubarb?
They
Okay.
have like body helping things.
Mhm.
My doctor.
Yeah.
Um,
Avocados are good for your brain. Bananas are good. Potassium is important in neurological functioning, and so are some of those fatty acids and stuff that you find in avocados. There's lots of stuff that's good for your brain. Why are chemists great for solving problems?
but they're chemists.
They have all the solutions. Yeah, that one's lame. Okay. The universal solvent is water. Okay, why do we call this the universal solvent?
You need it for everything you do everything.
Because it dissolves a lot of things. So we'll call it the universal solvent. Very often you'll hear it referred to as that because it dissolves all the polar stuff real easily. Now we talked about like how you ever try and anybody wash dishes at home? You help with washing dishes? You ever tried to wash a greasy pan?
No, I never.
It's hard to do, right?
Yeah.
But when you add dish soap to it,
It's
suddenly,
magic.
yes, and that's because the soap contains these bipolar molecules where it's called a surfactant, where one end will attach to the polar water molecule and the other end will attach to the non-polar lipid or fat molecule, and it allows the two of them to be joined so that when you rinse, they both go away together. Otherwise, your oil is never going to mix with your water, right? But you notice when you're like washing a pan with dish soap in it, it gets like this, you get like this thick, slimy, like, you know what I mean? It makes like a creamy mixture. Yeah, and it's because you've mixed up all that water and oil together. You've almost emulsified it in a way. So yeah, that's why dish soap works. And there's an example of surfactant in your body that is super duper important, and it's
Grinds everything.
no, it exists in your lungs.
Oh,
And surfactants tend to be slippery. Is dish soap slippery?
yep.
Yeah, you have surfactant in your lungs so that when you exhale, when you breathe out, all the little pouches in your lungs that are filled with air, when they're suddenly not filled with air, they're going to close up. If you ever like
like had your lips stick together, like when they're a little dry, like, you know, like they kind of get sticky, meh, 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 you know what I mean? They're just barely wet and they stick. That would happen to your lungs if you didn't have surfactant. The surfactant keeps them slippery. So when those little air pouches close up, they don't stick. Because if they stuck, then when you inhaled, you wouldn't be able to get any air and you would suffocate. But surfactant doesn't form until towards the end of fetal development. So babies that are born premature often haven't produced enough surfactant and they have to wait till their bodies catch up. So what they do is they'll put those babies on ventilator machines that breathe for them, but they don't breathe like this. They breathe like really fast, and they do it really fast because they're not giving those little air pockets time to close and stick. So it's this, if you ever look at like video of a tiny preemie on a monitor, you'll see their lungs are going like, and they're doing that on purpose, so they don't stick together. Did you have a question?
The baby's heart.
Not really, no. What were you gonna say?
Has anyone here bruised their butt?
Oh, I have the worst that story. I have the worst one.
I have like
Fall.
I have like some bruises.
Oh, yeah.
Around my knees and stuff, but
Lucy, when I was in college, my senior year, I spent every other weekend working at a nursing home because I had my nurse aide certification. And they had rails, handrails in the hallway for the elderly people. And they were like wooden dowels that were about this big around, right? And they were on the wall so you could hold them as you walked. And somebody was talking to me and I turned around and I backed into one, like the blunt end, like it was this thing around flat. And I backed into it and I had a perfectly round, like purple, like it was deep. It hurt so bad I couldn't sit. It was awful. Yeah, that and every time I have to get a big steroid shot, which I need a fair amount of the time for my lupus, I'll get a really bad bruise. So yeah, I know what you mean. All right, universal solvent is water. All right, I tell bad chemistry jokes because all the good ones are gone. Are gone. I actually have a wine tumbler with that on it that one of my former students made for me because she and her mom have a little business where they make t-shirts and cups, and she made me one of those and said all the good ones are gone. All the bad
Bad chemistry jokes because
all the good ones are gone. Are gone. Sorry, I actually like that one. So anyway, I love that little cup. It's fun. Yeah. Can you do two? Well, I can only give you credit for one, but if you really want to do two.
yeah.
So how well will you do on these questions? These are the questions that you've probably already done. Some of these are a little quick quiz. So are we looking at a suspension, a solution, or a colloid? And how do we know? Who wants to answer for me?
Me.
Everly, do you want to try? Do you think it's a suspension, a solution, or a colloid? What do you think? You know, like a homogeneous solution. Colloid, she said. Do you want to toss it to somebody? Colloid, she says. What do you say?
Say a solution.
A solution? What do you say?
solution.
Solution? All right, now let's think here. If we fill this bottle with glitter and we put it on the counter, what's going to happen to all the particles?
It's gonna.
They're going to settle, so it's a suspension. All right, how about this one? Oh, what's that?
Oh, it's called.
It's
Jello.
a Jello mold. What do we think? What do you think, Lucy?
Just Jello.
Oh, you were just stretching. What do you think, Annabelle?
I think it's a colloid, and when we were learning about this yesterday, I said, "Mom, why are you being a suspension?"
Suspension. You're so sus. So this one's a colloid. Good job. All right, because we have the sugar particles and whatever else surrounded by the little gelatin molecules, and it all goes together. And how about air?
It's a solution
Why is it a solution?
because carbon dioxide atoms.
Ooh, that's a tricky one. He's like, oh no, it's a solution. It is a solution because can you easily separate the nitrogen from the oxygen easily?
Nope.
No, but could you do it? We can do it.
Some
We can do it.
high tech stuff.
Yes, it can be done by a physical process, but it's gonna be a little more complicated, right? Now, air is a solution, water, like tap water is a solution. There are dissolved molecules within the water that make it a solution. So yeah, you know, solutions don't have to be liquids, right? Gas can be a solution. Another great example of a solution is brass. Brass is a solution. It's an alloy, but it's a solution.
How do you identify if a thing is a colloid?
It means that like all of the particles kind of evenly dispersed and they surround each other. It's kind of like they surround, you think about them kind of surrounding. Because the fat particles and the sugar, like the lactase and the casein, the protein, all those other parts of it will evenly kind of surround each other. If you leave it long enough, it does separate out.
Oh,
To
the
lift it to the top.
cream.
The cream goes to the top. All right, this guy.
Is it
Compounds which exist as solid ionic crystals dissolve in water as ions, and most of them are highly soluble in water. The positive and negative ions spread apart and are surrounded by water. Anybody know what that is? Want to guess what that is? It's ionic. You want to guess, Annabelle?
Is it a heterogeneous mixture?
Nope, this is pink halite, or what you know as Himalayan pink salt.
Oh.
Yeah, that's one of my favorites. It's so tasty.
Or a rose quartz from Mars.
Nope, yeah, rose quartz I love too, but that's pink halite. So that's pink Himalayan pink salt. I love Himalayan pink salt. It's delicious, I think. It's technically, they say it's a finishing salt because you're supposed to put it on at the end, not like at the beginning of when you're cooking, because it's very flavorful, right? I think it's way tastier than like table salt. Oh yeah, me too. So this is an ionic compound. Remember, they have a crystalline structure. Oh, look there, crystals, right? And they're brittle. Remember all the things about ions, right? When they dissolve in water, they conduct electricity, all that. Now, this one says dissolving a molecular solid requires breaking only the weak intermolecular forces, not the covalent bonds that actually hold the individual molecules together. Yeah, therefore molecular solids are relatively soluble in water. What happens if you put cotton candy in your mouth? It dissolves instantly. You ever put cotton candy on a drink, or on a drink? Does the same thing, it dissolves. I've seen people like put it on champagne, it looks really pretty, and then it dissolves, changes the color of the champagne. Ooh, right? Yeah, or you can put it on, I've seen it on milkshakes. There's a place in Virginia Beach that I love to visit. It's called the Yard Milkshake Bar. And that milkshake that was at the beginning of this slideshow, the pink one with the chocolate on top, that's nothing compared to what they do. They give you a little glass jar and they fill it with whatever your flavor is. And they have this, like, the one I first want to try was called their unicorn shake or something. But it had whipped cream, it was covered in candy, it had globs of cotton candy, it had like rainbow stripe gummy, whatever. It was crazy. And I had one, somebody I was with had one that had a whole brownie on top. So yeah, Emerson.
Right before you eat it, they put cotton candy.
I love it. And I must admit, I kind of have a weakness for the cotton candy flavored shake at Steak and Shake. If you've never had it, I highly recommend it. Yes, ma'am.
I just want to know what everyone's favorite flavor of cotton candy is. Mine is watermelon.
Oh, I don't know. I don't think I've ever met a cotton candy I didn't like. I haven't tried the pickle kind though. I may not
Dill
like it.
pickle.
You like the dill pickle cotton
I've
candy?
never tried it.
Oh, I've seen
I want
it.
to try it so bad. There's an ice cream shop that has all the weird flavors of candy, and it has a lot of ice cream.
I've never met an ice cream I didn't like either. Does anybody like Persian ice cream? That's one of my favorites. Usually you're gonna get it at like the Persian restaurants or the Mediterranean restaurants, but it's got saffron in it and rose water. It's kind of weird, but I love it. All right, so molecular solids are also going to dissolve in water, but in that case, you are only breaking the weak intermolecular forces. You're not breaking the actual compound. So when you put an ionic, think about it, when you put salt, NaCl, into water, it breaks into ions, right? Na plus Cl negative, right? It breaks into the ion, so it has broken down the actual compound. But when you put sugar into water, you're not breaking down the sugar molecule. You're just breaking the bonds between the individual molecules of sugar. So there are independent sugar molecules throughout it that hasn't broken down into those constituent components. So you still have sugar molecules in sugar water, but in salt water, you have the ions, right? That actually breaks the compound. All right, so that is pink dye in sucrose, so cotton candy. Yeah, you guessed right. The part of the solution that is present, everybody can do these together. The part of the solution that it is present in smaller amounts is the solute. The part of the solution that is present in large amounts is the, or you could say, what is dissolved is the solute. What does the dissolving is the solvent. All right, a colloid is a mixture containing small undissolved particles that do not settle out but are large enough to scatter light. Ah, that's something else. If you shine a flashlight through a glass of milk, that whole glass of milk kind of lights up because you're scattering the light. Okay, a fluid containing particles that can easily, fluid containing particles can easily, I think, be seen, and separated by filtration or settling is a suspension, a well-mixed mixture that contains a solvent and at least one solute is called, everybody, a solution. Explain what a solution is and how one is formed.
A solution is when a solute is dissolved in a solvent is dissolving, like when you mix sugar and water.
There you go. Anything else?
A solution forms when particles of the solid separate from each other and become surrounded by the particles of the solvent.
There you go.
One solid and it has the same properties throughout.
There you go. So a solution is made when one substance called the solute dissolves in another substance called the solvent. Dissolving is when the solute breaks up from a larger crystal or molecule into a much smaller group or individual molecules. This breakup is caused by coming into contact with the solvent. In the case of salt water, the water molecules break off salt molecules from larger crystal lattice. They do this by pulling away the ions and then surrounding the salt. I shouldn't say molecules because salt's not a molecule, right? This is copied from this website, so that's kind of an inaccuracy. You catch that there?
What?
It says salt molecule, but we don't call salt molecules, right? Because they're ionic, right? They're not covalently bonded, so they really aren't molecules. They're compounds or formula units. It is just now surrounded by water molecules instead of fixed to a crystal lattice. And this is a website where you can learn more. Duxterscience.com.
Hey, speaking of Duxters, my friends
Click on
Everson and Everly were being hacked or something by players named Duck Easy. I think it might actually be a bot, but
Oh, your like
It's a
gaming
bot.
account or something?
they were just receiving weird stuff from a bot named Duck Easy.
Duck Easy. Okay. Well, here's this Duxters page, and it says Chemistry for Kids, Solution and Dissolving. And if you look here, it talks about a lot of the things that we talked about before. And it gives examples of solutions, solutes and solvents. And then it shows some graphic images here of a heterogeneous mixture and a homogeneous mixture. And you can see how they're different. These are evenly dispersed, whereas these are not evenly dispersed. It further discusses dissolving, solubility. We're going to talk about solubility a little more, but solubility is a measure of how much solute can be dissolved into a liter of solvent or any unit, really. We often use liter though. And you think of your example as salt and water. You keep pouring salt into water. At some point, the water isn't going to be able to dissolve the salt. And then we talk about being saturated. So I think this is in your next lesson, but saturated means it can't take any more solute. You keep putting in solute, it won't dissolve anymore. It's dissolved all that it can dissolve. Next week, I'm going to show you a really cool demo with a super saturated solution of sodium acetate trihydrate, which does some really cool stuff when it is super saturated. Yes.
Which car company puts the most iron in their cars?
I don't know who.
Santa Fe.
Santa Fe, F-E. Yeah, there you go. That's a good one. Santa Fe. That's a Hyundai.
Do you make up
Yep.
jokes or can you copy it from there?
You have to pick one from the show, the slideshow.
Why did the bullet lose his job?
The bullet. What'd it do?
He got fired.
Oh, that's a good one. Y'all hear my dad when he was here and he's like, he always likes to do, because he's usually here around Christmas or whatever. So he always likes to do, where does the snowman keep his money? In the snowbank. I got him a book of dad jokes for Christmas, which is gonna take him a long time to get through because he doesn't read well at all. He barely reads.
Dad
So it'll be real fun.
has a dad joke book, and one of them says, I watched a show about beavers. It was the best damn thing I ever saw.
That's a good one. That's a good one. So we talk about being saturated. That's when it can't take any more than it can hold. And that's like if you're at room temperature and you're adding salt and suddenly you can't, it just won't dissolve. You stir, it won't dissolve. The way to super saturate a solution is usually, if you're talking about a liquid, to heat the liquid, then it can absorb more. You can also, if it's gas, you can cool down the liquid and it will absorb more than it typically could. Miscible and immiscible talks about whether or not liquids can be mixed together, whether or not like oil and water are immiscible. You can't put oil into water and have one dissolve the other. It doesn't work, right? But something is miscible means it can dissolve.
Oil to the bottom of the water.
The other way around. Oil goes to the top because it's less dense. Lipids are less dense than water. So,
And sugar and water are miscible.
yes. So if you look right here, it says interesting facts about solutions. There's a solvent called aqua regia, which can dissolve the noble metals, including gold and platinum. See, regia right here, this is where your Greek and Latin roots come in. This has to do with royalty, like king and queen. Guys, watch your volume. Thank you. So you're seeing noble metals, gold and platinum being like your most expensive ones. So that makes sense. You can't see a beam of light when shining it through a true solution. This means fog is not a solution, it's colloid, right? Because you can see light going through fog. Solutions can be liquid, solid, or gas. An example of a solid solution is steel or brass, like I said before, which is also, we call those an alloy when we're talking about metals. And solutions are generally more soluble at higher temperatures if we're talking about liquids. And carbonated beverages are made by dissolving carbon dioxide into liquid at high pressure. So we increase the pressure, we decrease the temperature, and we can usually get a fair amount of gas. And if you want to study, there's a 10-question quiz here that you can do, but I'll leave that to y'all for later. So yeah, you don't have to ask, you just go ahead. All right, so that's that. Let's see if we can get this rest of this crew in here. If I can make, hello, why won't you? There you go. Oh my, all right. Maybe it's not liking me today. There we go.